Hello viewers, in today's session we are going to discuss another important and conceptual problem from differentiability of functions, and here we are going to check the differentiability of this function f of x, which is given by absolute value of x plus 5, and we have to examine whether this function is differentiable at this point x is equal to minus 5, right? And here in order to check the differentiability of this function, we are going to make use of the concept of right hand derivative and the left hand derivative at this point x is equal to minus 5. So now consider a function, say y is equal to f of x, which is defined in some domain D, right? And this function is said to be differentiable at some point, say x is equal to a, belonging to the domain of this function if the right hand derivative and the left hand derivative of this function at x is equal to a, it exists, and both the derivatives are equal to each other, right? So if the right hand derivative of this function, that is r f prime of a, is equal to the left hand derivative, that is l f prime of a, then this function is said to be differentiable. So if the right hand derivative and the left hand derivative both are equal to each other at this point x is equal to a, then we conclude that the derivative of this function at this point, it exists, and this function is differentiable at x is equal to a, right? So here we have to first find out the right hand derivative, and then we'll find out the left hand derivative. So the definition of right hand derivative is given by this limit, that is limit h tends to 0. Here we have f of a plus h minus f of a divided by h, right? And the left hand derivative is defined by this limit, that is limit h tends to 0, and we have f of a minus h minus f of a divided by minus h, right? So the function is said to be differentiable at this point if limit h tends to 0, and we have f of a plus h minus f of a divided by h is equal to this limit, that is limit h tends to 0, f of a minus h minus f of a divided by minus h, where h is infinitesimally very small and h is greater than 0. So if the right hand derivative at this point x is equal to a is equal to the left hand derivative at x is equal to a, then the function is said to be differentiable at x is equal to a, and the common value of the right hand derivative and the left hand derivative is given by the derivative of the function, and it is simply denoted by f prime of a, right? So here a is minus 5. So we have the right hand derivative, that is r f prime of minus 5, is given by limit h tends to 0, f of minus h plus f of minus 5 plus h minus f of minus 5 divided by h. So now we can write limit h tends to 0, and f of minus 5 plus h can be obtained by replacing x by minus 5 plus h over here. So we have a mod of minus 5 plus h plus 5, and f of minus 5 can be obtained by replacing x by minus 5. So we have mod of minus 5 plus 5, and here we have h. So now we have limit h tends to 0. Here 5 and minus 5 get cancelled, and we have mod of h. And here we have 5 and minus 5 get cancelled. We have mod of 0. Here we have h. So we have limit h tends to 0 and mod of h, right? So mod of h is equal to h because h is greater than 0, right? Because we know the definition of mod function, that is mod of p is defined as positive p when p is greater than or equal to 0, and negative p when p is less than 0, right? So here if we take p is equal to h, then h is greater than 0, it is positive. So from this part of the definition, mod of h is equal to positive h, or simply h, right? So here we can now replace mod of h by positive h, and here it is mod of 0 is 0. Here we have h, and limit h tends to 0, and this is h minus 0 is h, and here we have h, and limit h tends to 0, h and h get cancelled, and here we have 1. So now limit h tends to 0, 1 is simply equal to 1 because this term is independent of h, right? So the right hand derivative of this function at x is equal to minus 5, or a is equal to minus 5, is equal to 1. So now let us find out the left hand derivative. So the left hand derivative is given by this limit. So we have limit h tends to 0, and we have f of a minus h. So a is minus 5, so we have minus 5 minus h, and then we have f of minus 5, and in the denominator we have minus h. So now we can write limit h tends to 0, f of minus 5 minus h can be obtained by replacing x by minus 5 minus h in this function. So we have mod of minus 5 minus h, and here we have plus 5, and f of minus 5 is given by mod of minus 5 plus 5, and here we have minus h, and limit h tends to 0. Here 5 and minus 5 get cancelled. We have mod of minus h, and here we have as we have done in finding out the right hand derivative, this term is 0, and here we have minus h. So now we can write limit h tends to 0 and mod of minus h over minus h. So now to get the value of mod of minus h, we are going to make use of this definition, and here we'll make use of this part of the definition, right? So here now for p we have minus h, so replacing a p by minus h, and h is greater than 0, so minus h is less than 0, right? So here p is less than 0, then a mod of p is equal to negative p. So now mod of minus h is equal to negative of h, because negative of h is less than 0. Here p is less than 0, so negative multiplied with negative, it becomes positive, right? So now here we have limit h tends to 0, and we have positive h over negative h, and h get cancelled. We have limit h tends to 0, and here we have minus 1, right? So this limit is equal to negative 1 because this term is independent of h. So the left hand derivative of this function at a is equal to minus 5 is equal to minus 1. So now we see that the right hand derivative, that is r f prime of minus 5, is not equal to the left hand derivative, that is l f prime of minus 5, because 1 is not equal to minus 1, right? So the right hand derivative is not equal to the left hand derivative at this point x is equal to minus 5. Therefore this function, that is f of x is equal to mod of x plus 5, is not differentiable at x is equal to minus 5, right? And moreover, from this function we can see that the domain of this function is the set of real numbers, right? So here x belongs to the set of real numbers, and this function is continuous for all values of x. But here this function is not differentiable at only this point, that is x is equal to minus 5. But for other values of x the function is differentiable, right? So this function is continuous for all values of x belonging to r, and this function is not differentiable at x is equal to minus 5, and it is differentiable for other values of real numbers except x is equal to minus 5. So this function has only one point at which this function is not differentiable, and the point is x is equal to minus 5.